is WOCA, Ocala, Gainesville, The Villages, 1370 AM, 96.3 FM, The Source.
All right, 10 minutes before 11 o'clock. Here in Central Florida, we are kind of used to the idea that there are rockets that take off to the southeast of where we are, and it's always fun and exciting to know the time when they're going to go up. A night launch is always our favorite.
Oh, I love them.
Because we're far enough away that when a day launch happens, you can see it, right? You can see the flame, but night launch, it lights up everything, right?
Amazing.
As long as the clouds are behaving. Well, there is a launch today, and I don't know if the word launch applies in this case. Let me just read what the news says. It says here that today, Northrop Grumman will attempt to air launch, there's a new word for us, air launch, its Pegasus XL rocket that will send NASA's $252 million Ionospheric Connection Explorer science mission, or ICON for short, to study the region of near-Earth space. Mm-hmm. Okay. So you know what that's about? Not me. Okay, I'm going to pretend I do, but I don't really. Dr. Jeffrey Klenzing is on the phone. He serves as the NASA mission scientist for the Ionospheric Connection, the ICON Explorer mission. He's going to explain what this is, and I don't know what time this is going up, so maybe that'll be my first question. Good morning, Dr. Klenzing. It's an honor to have you on the show.
Good morning. It's good to be here.
Are you in Cape Canaveral right now?
No, I'm in Maryland.
In Maryland, okay. Are you part of this program, this Ionospheric Connection ICON thing?
I am. I'm working more on the science side of things, but yeah.
Okay, so the news, I'm trying to see where I saw this. 39,000 feet up there, and then the spacecraft will leave from another aircraft?
So basically, it's launching off of a rocket. The Pegasus rocket is basically strapped to the bottom of an aircraft.
Oh my gosh.
And so that flies it up to about 40,000 feet. And then out over the Atlantic Ocean, they'll drop it, and after a few seconds, the engines will ignite and launch it into space from there.
But there's somebody still on the first airplane, right?
Yes, there's a pilot and crew on the aircraft.
On both things? Is there somebody on the ICON also?
No.
Okay.
No, it's a autonomous mission.
Oh my gosh.
It's what we call an Explorer class mission, so it's a smaller payload than the typical satellite, and so it can be launched from this Pegasus system.
I'm assuming this is something we will not be able to see. It sounds like it's a little too far out.
Yeah, I think this is, especially at night, this is going to be out somewhere over the Atlantic.
What time?
When they launch.
What time?
I think the launch window opens at 9:15.
Oh, tonight! Oh my gosh! Okay, so somebody's fishing out there on a boat. Are they going to think they're seeing a UFO or something?
Could be.
This is a very important mission because of the weather, the space weather in traveling to the moon. But the ICON is also going to be teaming up with something named Gold.
That's right. So space weather is basically, you can think about the weather on Earth, storms and things like that. We have something similar in space, and this actually starts affecting us near the upper regions of the atmosphere as well. So like where the space station is, and also, if we send astronauts out farther back to the moon, it's going to affect them more in the interplanetary environment. And so ICON and Gold are both looking at more of the Earth atmospheric effect side of things. So we're looking at the ionosphere, and this affects our radio propagation and things like that, so GPS communication signals. Gold is a mission which launched about 2 years ago, and it's in a geostationary orbit, basically parked over the Western Hemisphere, which is sort of looking at the big landscape, kind of the full view of the atmosphere. ICON is going to be at about 360 miles above sea level, and it's going to be looking at sort of the small scale, the smaller picture type stuff. And so between these two, we can start getting not only a better idea of what the local forcing is, but sort of the big picture as well.
And you also say that the view from what ICON has, that it also will see like red and green lights in the atmosphere.
That's right. So So these lights are called air glow. This is basically it's a natural emitting light from our atmosphere. As the sun is pouring energy into the air, it's exciting the atoms and molecules, and they start emitting light. And they start emitting these very specific red and green bands. And so ICON is going to look at the red and green bands, and it's going to use that information to determine what's going on in the atmosphere. What are the winds? What are the temperatures? What's driving these space weather effects that we see higher up?
So how did we go to the moon and do all the other things that we've done before this? Does the information make it easier or safer?
This will help us. This will help us better understand it. So the primary connection between this would be potential communication outages and things like that. Mm-hmm. And this is sort of a larger worldwide effect. I mean, our big effect on Earth right now is that it would be affecting navigation signals for airplane navigation, potentially self-driving cars and things like that. As we're becoming more and more reliant on technology in our day-to-day lives.
Oh, gotcha. Okay.
These effects we're going to see more and more of these effects.
Okay, so I was misunderstanding. I was thinking this was information that would help us leave the planet to go to outer space things, but in fact, this is for on-Earth information.
Yeah, it's for both. It will also help us communicate better with space missions.
When the ICON is launched, is there going to be a no-fly zone around the launch area?
I believe so.
And how long will that last, the no-fly zone?
I don't know that information.
Because Robin was going to go flying, but...
Yeah, I'm assuming the FAA is taking care of that.
So I read in the USA Today article that we should be able to watch this on NASA TV?
Yes, there will be live streaming tonight.
So will ICON have a permanent orbit, or will it be returning to be used again?
No, it will be an orbiting mission. We're planning for 2 years of operations, and we'll extend it beyond that.
Oh my gosh! So it's circling the Earth for 2 years?
Yeah.
Will we be able to see it? Like every once in a while, like Robin has this thing or something that tells her when the space station is going over, and I've seen it. I wouldn't have known it was that if she didn't tell me.
Yeah.
But
yeah, ICON is a lot smaller than the space station, so it might be harder to see, but perhaps with the right telescope.
It's considerably closer, though, right?
No, actually, it's going to be above the space station.
Oh my gosh! Really?
Oh my gosh!
Oh,
yeah.
Okay, well, never mind then.
So, what type of plane? How did you determine the type of plane that will be used to launch this rocket?
So this is determined in part with our partners at Northrop Grumman. This is what they call a Pegasus XL mission, and it's basically it's a specially designed and modified plane that they have for launching small payloads like this.
Mm-hmm. Is there a reason why we hadn't launched rockets this way in the past?
We have, actually. It's just not an everyday occurrence.
Oh, okay. And is there a reason why this one was done this way and not the traditional vertical way?
Part of it is just because it's a smaller payload.
Okay.
It's about 300 pounds satellite, which is smaller than, let's say, a communication satellite or something else that you're boosting up to a higher altitude or higher inclination orbit.
So just so we understand how this affects us, this will make self-driving vehicles more, I guess, safer? Is that the way to say that?
Well, so the idea is that if you're dealing with something that requires very precise GPS navigation, and usually these will be things like aircraft systems and things like that. What can happen is structures in the ionosphere interfere with it. So, picture you're looking up, and you could see a GPS satellite above you. You're basically looking through the ionosphere. And so if you're sending that signal up and you start getting all sorts of structure in it, it's like looking through a piece of glass that's all warped or has a bunch of bubbles in it.
Gotcha, okay.
And so, you start to get mirror images of things, you get dispersion, and it becomes hard. You start to get a little bit of error on that signal.
Oh, how fascinating is this? I love this.
Well, it is somewhat over my head, I'll be honest, but I would like to invite the listeners to learn more. Is the website nasa.gov? Is that the best place to go?
Yeah, go to nasa.gov.
Okay. Well, thank you. I know you're busy today. It's a very exciting day. Thank you, Dr. Klenzing, for talking to us today.
All right, thank you very much.
You're welcome. We'll be right back.
This is a Fox News alert. I'm Lillian Wu. A Turkish military operation underway in northern Syria, where warplanes are carrying out airstrikes on civilian areas. This according to U.S. allied Kurdish forces there.
We're getting reports